How vast is the home of humanity? The question drifts across the silence of the night sky, where billions of stars weave themselves into a luminous river, arching like a ghostly bridge of fire across the blackness. Each point of light is a sun. Each sun may cradle worlds, and yet together they form only a fraction of the galaxy that holds us. For centuries, the Milky Way has been our compass and our abyss. Ancient travelers measured their lives against its glow. Philosophers dreamed of its meaning. Astronomers tried to weigh its immensity, yet always fell short, blinded by distance and by the sheer scale of what lay before them. Our entire history, our wars and our art, our memories and our myths, all unfold inside this one galactic cradle. But the cradle itself seemed infinite, a horizon without edges. The Milky Way has been called a cosmic cathedral. Its pillars are forged of stars. Its corridors stretch into shadows where even our most powerful telescopes hesitate. Walls unseen, arches of light dissolving into darkness. We stand inside it, unable to step back, unable to grasp the architecture of the very structure that gives us shelter. And yet, the question persisted. How wide is this cathedral? How deep are its chambers of starlight? After centuries of guessing, of illusions mistaken for truths, of paradigms shattered one after another, science has carved out an answer. We now know the Milky Way's scale. But with that knowledge comes a deeper unease, for the truth is stranger than we dared believe. Our galaxy is vaster, more uncertain and more mysterious than imagination ever allowed. It is not just our home. It is a riddle written in stars. Long before telescopes and mathematics, before equations tried to measure the sky, the Milky Way was seen as a river of light. Across deserts, jungles, and oceans, ancient civilizations gazed upward and gave the luminous band a name born of myth. To the Greeks, it was the milk of Hera spilled across the heavens. To the Chinese, it was the silver river separating two star-crossed lovers. To the Maya, it was the backbone of the sky, the dwelling place of gods and spirits. Though stories differed, a shared awe united them all. The Milky Way was not only a guide in the night but a mystery written in fire. Through countless generations, its glow remained a riddle. No eye could separate its mist into stars. It seemed a continuous cloud, a veil of celestial smoke. This illusion held until a single man, peering through a modest tube of glass in 1609, tore the veil away. Galileo Galilei aimed his telescope toward the Milky Way and discovered something astonishing. The smooth river was no mist at all. It was an ocean of countless stars, so densely packed that they blurred together in the naked eye. In his notes, he marveled at the multitudes invisible before, describing innumerable stars filling the blackness. With one gesture of observation, the universe became both more wondrous and more unfathomable. Humanity had stepped closer to the truth, yet with each step, the horizon retreated. The centuries that followed brought new seekers of the galaxy's secret shape. Among them was William Herschel, an 18th-century astronomer whose passion for the night drove him to count the stars themselves. Night after night, he swept his telescopes across the heavens, tallying the stars in every direction. He imagined the Milky Way as a vast disk, a flattened system with the sun placed humbly near its center. His maps, built from patience and perseverance, were the first tentative sketches of our home. Yet Herschel's vision was flawed. His telescopes reached only so far, and dust clouds veiled much of the galaxy. What he drew was not the whole but a shadowed outline. Still, it was a daring attempt to measure the immeasurable. For the first time, the Milky Way was more than a myth. It was a structure, a thing with shape and boundaries waiting to be revealed. As the 19th century gave way to the 20th, a new breakthrough emerged. Harlow Shapley, studying the globular clusters, those dense spherical swarms of ancient stars, realized they were not scattered at random. They circled around a point far from the sun. By mapping their distribution, Shapley uncovered the hidden truth. The Milky Way was vastly larger than anyone had imagined, and the sun was not at its center. Humanity's cosmic ego shrank once again. What seemed a throne became a seat on the edge. The revelation was profound. Our galaxy was not a mere neighborhood of stars clustered tightly around us. It was a sprawling city of light with a hidden core, billions of years old, stretching farther than telescopes of the time could grasp. Shapley's work shattered the illusion of centrality. Earth was not the axis of the cosmos, nor was the sun. Even our position within the Milky Way was peripheral, an exile from the center's brilliance. Soon after, a new kind of vision emerged, one that did not depend on visible light. Radio astronomy opened the sky to unseen wavelengths, piercing through the veils of dust that had blinded optical telescopes. What had once been impenetrable shadows now revealed hidden architecture. By tracing the emission of hydrogen gas, astronomers began to discern the spiral arms of the galaxy. What the ancients had called a river and Herschel a flattened disk was revealed as a spiral cathedral of stars. Sweeping arms curved outward from a luminous hub, winding through darkness like colossal rivers of fire frozen in rotation. This was a profound shift. The Milky Way was not a cloud or a haze. It was a dynamic structure, an organism of gravity and motion. Each arm a stellar nursery, each sweep a record of cosmic history. The galaxy was alive, endlessly turning, endlessly birthing, endlessly devouring. Yet even as this structure came into view, another revelation broke the limits of imagination. Edwin Hubble, peering through the 100-inch Hooker telescope on Mount Wilson in the 1920s, studied faint patches of light once thought to be part of the Milky Way. They were called spiral nebulae, mysterious smudges hanging at the edge of visibility. Hubble measured their distance using Cepheid variable stars as cosmic lighthouses. The result was staggering. These spirals were not inside our galaxy. They were galaxies themselves, each containing billions of stars. The Milky Way, once thought to be the universe entire, was reduced to one island among billions. An ocean of galaxies stretched beyond, each perhaps larger, stranger, more ancient. Our galaxy was not the cosmos. It was a grain of sand on a boundless shore. From Galileo's modest telescope to Shapley's clusters, from Herschel's star maps to the invisible arms revealed by radio waves, the story of the Milky Way is one of illusions broken and horizons redrawn. Each discovery answered a question while raising one more profound. How wide is the Milky Way? How deep its corridors? And if our galaxy is only one among billions, what then is the scale of everything beyond? The quest to measure our home became the quest to measure the universe. But within that search lies a haunting paradox. The more we discover, the more fragile our place becomes. The river of light that once defined the sky now dissolves into a cosmic archipelago without end. And still the Milky Way calls to us, its true boundaries both revealed and concealed, a labyrinth of stars awaiting the next seeker to chart its unseen halls. In the early centuries of astronomy, the Milky Way was a riddle without edges. Telescopes multiplied stars beyond count, yet their arrangement remained a mystery. The first estimates of its size were daring guesses cast into the dark. Some imagined the galaxy to be no larger than a few thousand light-years across, a modest island of stars. Others proposed figures so immense that they rivaled the scale of the visible universe itself. The numbers swung like a pendulum, too small, then impossibly vast. Each estimate revealed less about the galaxy than about the audacity of human imagination. The shock was not in the numbers alone, but in the revelations they carried. In the 18th century, William Herschel believed the sun to be near the center of the Milky Way's disk. His star count seemed to suggest a symmetry around us. Humanity was still perched at the axis, still able to imagine itself as central in the grand architecture of the stars. But as techniques sharpened, the illusion fractured. By the early 20th century, Harlow Shapley's mapping of globular clusters showed the truth. The Milky Way was immense, 100,000 light-years wide, and the sun was not at its heart. It was adrift on the margins, 30,000 light-years from the galactic center, a provincial star circling far from the core. The universe had humbled humanity once before by dethroning Earth. Now it did so again, casting even the sun from the throne. The revelation was disorienting. To know that all of human history, all civilizations had unfolded in a suburb of the galaxy, was a blow to the imagination. What once felt central became peripheral. What once seemed contained became infinite. The Milky Way had become not only vaster than anyone had conceived, but also profoundly decentered. Humanity was not merely small. It was off to the side. Yet the struggle to measure the Milky Way did not end with Shapley. The galaxy resists simple cartography. Mapping it from the inside is like trying to sketch the outline of a forest while standing among the trunks. Stars veil stars. Dust curtains block the light. Distances warp perception. Each telescope peers outward into a maze without walls, each attempt to measure like a blind hand feeling for edges in the dark. Light itself conspires against us. Vast clouds of interstellar dust scatter and absorb starlight, making regions of the galaxy vanish into apparent voids. What looks like emptiness is often an illusion. a shadowed corridor hiding rivers of stars behind veils of carbon and silicate grains. Even the brightest stars can be dimmed beyond recognition by the fog of the interstellar medium. To map the galaxy, astronomers must peer through layers of distortion, each measurement refracted by the veil that surrounds us. As instruments grew more powerful, new layers of the Milky Way's hidden architecture began to emerge. Beyond the luminous disk with its spiral arms lies a vast faint halo. It is a ghostly sphere of ancient stars in globular clusters, stretching far above and below the galactic plane. These halo stars orbit in paths far from the bright river of the Milky Way, remnants of collisions with smaller galaxies long since devoured. Their orbits trace a history of cosmic cannibalism, each cluster a fossil of ancient mergers. But even this halo was only the beginning of a deeper revelation. When astronomers measured the motions of stars and gas in the galaxy, they discovered something profoundly unsettling. The stars moved too quickly. Their velocities could not be explained by the visible matter alone. By every law of Newtonian mechanics, the Milky Way should have flown apart. Yet it held together. The invisible hand restraining it was unseen mass and unseen structure. This discovery marked the unveiling of the galaxy's greatest secret. Surrounding the Milky Way is a vast envelope of dark matter, a halo not of stars but of something stranger. It extends far beyond the luminous disk, perhaps 10 times farther, an invisible sphere anchoring the galaxy in place. Dark matter neither emits nor absorbs light. It cannot be seen directly, but its presence is undeniable, betrayed by the way it bends the paths of stars, the way it curves the orbits of galaxies and clusters, the way it sculpts the very fabric of the cosmos. The shock was profound. The Milky Way, once thought to be a river of stars, was revealed as a ghost ship. Its visible light was only the lanterns on its deck. The true vessel was a hidden mass, dark and immense, outweighing the stars by a factor of 5 or more. Humanity had not only underestimated the size of the galaxy, it had underestimated its very substance. Most of the Milky Way is invisible. Most of what holds us together cannot be touched or seen. This realization deepened the mystery of scale. If dark matter shapes the galaxy, then the true Milky Way is not 100,000 light-years wide, but perhaps 1,000,000. Its halo reaches far into intergalactic space, overlapping with the invisible spheres of neighboring galaxies, binding them together in a cosmic web. The edges of our home dissolve into the edges of others. Where the Milky Way ends and another begins becomes an almost philosophical question. In this lies the haunting paradox of measurement. Every attempt to define the size of the Milky Way leads to deeper uncertainty. Its luminous arms can be traced. Its central bulge can be mapped. But its invisible halo stretches beyond sight, perhaps beyond imagination. What is the size of a structure whose borders cannot be seen, whose substance cannot be touched? The very act of measurement becomes an act of humility, a recognition of how little is visible in the cosmic night. The shock of discovery has always carried 2 faces. One is the exhilaration of revelation. The Milky Way is vaster, more complex, more beautiful than we dreamed. The other is the abyss of uncertainty. The more we uncover, the more elusive its true dimensions become. Humanity has moved from myths of rivers and milk to telescopes and equations, yet the galaxy remains a riddle. Its corridors stretch farther than we can measure. Its walls are built of matter we cannot see. The scientific shock of the Milky Way is not only in its immensity but in its strangeness. The home of humanity is not what it appears to be. It is a cathedral built on shadows, a luminous disk afloat in an invisible sea. And every star, every world, every memory of life on Earth drifts within this hidden architecture, held together by forces that remain unknown. The story of the Milky Way's size did not end with the shock of displacement or the unveiling of dark matter. Each revelation only sharpened the tools of inquiry. If the galaxy could not be seen whole, then it would be mapped piece by methods ingenious and relentless, reaching into wavelengths the human eye could never grasp. The mid-20th century brought a revolution of listening rather than looking. Radio telescopes rose like steel giants, capturing whispers from the depths of the galaxy. Where optical light was blocked by veils of interstellar dust, radio waves passed through unimpeded. What had been shadows became structures. In 1951, astronomers mapping the 21-centimeter emission line of neutral hydrogen traced the spiral arms of the Milky Way in detail for the first time. The galaxy was no longer just a hazy river or a flattened disk. It was a grand spiral, its arms curling outward like rivers of fire stretched across hundreds of thousands of light years. But distance remained the great obstacle. A spiral is easy to trace in a distant galaxy, seen from the outside as a swirl of light. From within, perspective collapses. The galaxy becomes a maze without a map. To measure its scale, astronomers turn to the steady heartbeat of stars. Cepheid variables with their rhythmic brightening and dimming offered a cosmic yardstick. Their pulsations revealed their true luminosity, and by comparing this with their apparent brightness, distances could be measured across vast gulfs of space. The same principle applied to pulsars, the spinning remnants of dead stars whose radio pulses marked time with atomic precision. Each standard candle illuminated another corner of the Milky Way's architecture. With each refinement, the galaxy grew in detail, but also in complexity. The Gaia Space Observatory, launched by the European Space Agency in 2013, transformed this pursuit into an endeavor of breathtaking scope. By 2025, Gaia had mapped the positions and motions of nearly 2 billion stars, charting the Milky Way with a precision once unimaginable. The data revealed the galaxy not as a static structure, but as a living system, constantly shaped by gravity, collisions, and tides. Stellar streams, remnants of devoured dwarf galaxies, snaked through the halo like faded scars of ancient battles. Rogue stars, flung from the galactic center by encounters with the supermassive black hole, shot outward at hundreds of kilometers per second, becoming exiles racing toward intergalactic space. Gaia's maps unveiled another startling truth. The Milky Way is not flat. Its disk, far from a smooth plane, is warped and twisted, bent like a vast ribbon in motion. The cause lies in gravitational interactions with satellite galaxies, the large and small Magellanic Clouds, whose orbits tug and pull at the Milky Way's edges. These smaller companions act as cosmic sculptors, distorting the galactic plane into a ripple that sweeps through the disk. The shape of the Milky Way is not a perfect spiral, but a spiral caught in motion, its edges bent by the pull of its neighbors. At the outskirts of the galaxy, the mystery deepens. Beyond the luminous spiral arms lie faint stars scattered like sparks from a fading fire. Some belong to stellar streams, ghostly trails left behind by galaxies torn apart by the Milky Way's gravity. Others cluster into ultra-diffuse structures, faint companions whose stars are spread so thin they barely shine. These fragile systems, barely held together, drift at the edge of visibility, their existence discovered only in the last few decades. They blur the boundary between galaxy and intergalactic space, raising questions about where the Milky Way truly ends. The puzzle of faint stars pushes the limits of detection. Telescopes strain to gather their dim light, each photon a clue to the galaxy's outer structure. What lies beyond them remains uncertain. Is the halo filled with countless unseen dwarfs, ultra-faint galaxies dissolving into the dark? Or is the Milky Way already reaching the edge of its domain, merging into the emptiness between galaxies? Each new observation adds layers of complexity rather than clarity. Radio waves reveal spiral arms invisible to optical light. Cepheids and pulsars provide rulers for space. Gaia's maps expose streams, twists, and ripples, and yet the more the galaxy is charted, the less it resembles a neat diagram. The Milky Way emerges as a dynamic, distorted, living entity. Its arms are not perfect spirals but winding rivers that fragment and reconnect. Its disk is not level but warped and restless. Its halo is not empty but scarred with remnants of ancient galaxies. The deeper the investigation, the more the galaxy resists simple definition. It is no longer a disk or a spiral, but a tapestry woven from stars, gas, dark matter, and memory, a system sculpted by both creation and destruction. Each faint star at the edge, each twisted ripple in the disk, each rogue traveler escaping into the void, tells part of the same story. The Milky Way is not static, but a history written in motion. The question of size becomes even more elusive. If the spiral arms define the galaxy, then it is perhaps 100,000 light-years across. If the halo defines it, then it stretches several 100,000. If the dark matter envelope is included, then the true Milky Way may span nearly 1,000,000 light-years. The galaxy is not a single shape, but many nested within one another, each defined by a different kind of matter. Luminous stars, invisible gas, tidal streams, and dark matter all sketch different boundaries, none of them final. To map the Milky Way is to chase a moving horizon. The galaxy that cradles humanity is not a static home but a shifting sea. Its shape bends under unseen forces, its edges blur into faint companions, and its heart pulses with stars whose distances can only be guessed at. Even as Gaia's precision reaches billions of stars, there remain countless more unseen, too faint, too distant, too shrouded in dust to be measured. The deeper the investigation, the more the galaxy appears as a paradox. It is both charted in exquisite detail and yet profoundly unknown. It is mapped with billions of coordinates, yet its true shape remains unsettled. The Milky Way is not a finished structure to be drawn on a map, but an evolving organism caught in the act of becoming. And within it, the fragile spark of life on one small world tries to measure the cathedral that holds it. Beyond the luminous spiral arms and the glowing river of stars lies a realm almost invisible. It is not traced by starlight but by the faintest shadows of movement. This is the halo of the Milky Way, a sphere so vast it dwarfs the familiar disk. If the galaxy's spiral is its body, then the halo is its ghost, extending hundreds of thousands of light years into the void. Within it drift ancient stars, scattered globular clusters, and faint dwarf galaxies. The halo is not decoration. It is the true bulk of the Milky Way, stretching far beyond the reach of the naked eye. The halo is not silent. It carries the scars of a violent history. Across its expanse, astronomers have discovered stellar streams, rivers of stars pulled from smaller galaxies that ventured too close. They trail across the sky like pale ribbons, remnants of collisions millions of years old. Each stream is a memory, a testimony that the Milky Way grows not by quiet expansion but by consumption. Our galaxy is a predator, devouring its neighbors and weaving their remains into its own halo. The Sagittarius dwarf galaxy, once an independent system, is now stretched into tatters by the Milky Way's gravity, leaving streams that wrap around us like torn cloth. Other streams betray the fates of yet smaller galaxies, shredded into strands too thin to be seen without careful surveys. What appears from Earth as a serene band of light is in truth an active battlefield, where the Milky Way feeds on its companions. This revelation reframes the galaxy not as a stable structure, but as an organism, always in flux, always reshaping itself. Beyond this cannibalism lies an even greater encounter, written into the future. The Andromeda Galaxy, our nearest giant neighbor, looms across the intergalactic gulf 2.5 million light-years away. Gravity binds the two in a slow and inescapable embrace. In 4 billion years, the Milky Way and Andromeda will collide, their halos touching long before their disks meet. For now, they are locked in a dance, spiraling toward one another with the inevitability of tides. The future of the Milky Way is not isolation but merger, an entanglement that will birth a new structure, an elliptical titan sometimes called Milkomeda. The galaxy we call home is only temporary, a phase in a larger cycle of cosmic transformation. Even as this future looms, the present is filled with uncertainty. Astronomers still cannot agree on the Milky Way's true weight. Some estimates suggest the galaxy contains the mass of 1 trillion suns. Others argue for nearly twice that amount. The difference is staggering, enough to decide whether the Milky Way is a modest spiral or among the giants of the cosmos. The difficulty lies in what cannot be seen. Most of the galaxy's size and mass is invisible. Stars, nebulae, and glowing arms form only a thin layer. Beneath them lies dark matter, the enigmatic scaffolding that holds the galaxy together. Without it, the Milky Way would fly apart. With it, the galaxy's halo stretches far beyond what telescopes can trace. But dark matter reveals itself only indirectly, through the speed of orbiting stars, through the way galaxies cluster, through the subtle bending of light across space. It cannot be weighed like stone nor mapped like stars. It is a presence inferred from its grip, a substance known only by the shadows it casts in the behavior of the visible universe. This leaves the Milky Way's size as an unsettled question. If the boundary is the edge of the spiral disk, then the galaxy spans about 100,000 light-years. If it includes the stellar halo, then the scale swells to 300,000. If the full dark matter envelope is considered, then the Milky Way may stretch nearly 1 million light-years across, its edges brushing against the halo of Andromeda. The galaxy's boundary is not fixed but blurred. It shifts depending on what one chooses to measure, stars, gas, or the invisible ocean of dark matter. This uncertainty is more than a technical detail. It reshapes the way humanity thinks of its place in the cosmos. The Milky Way is not a closed island but a porous system, its outskirts tangled with faint dwarfs, stellar streams, and the gravity wells of other galaxies. Its edges are dissolving, merging into the cosmic web that stretches between clusters and voids. To ask where the Milky Way ends is to ask where any galaxy ends, and whether such edges exist at all. The escalation of discovery has deepened the mystery rather than resolved it. What once seemed a luminous disk of stars is revealed as a sprawling, shifting system. Its halo is immense, its diet cannibalistic, its mass uncertain, its future destined for collision. The Milky Way is not a stable home, but a transient structure in the cosmic flow, bound by dark matter to a destiny it cannot escape. In the end, the most unsettling truth is not only that the galaxy is vaster than imagined, but that most of it is invisible. The stars that define the night sky are ornaments on a deeper, darker scaffold. The glowing arms are surface ripples on an ocean whose depth cannot yet be fathomed. Humanity's home is larger, stranger, and less certain than the imagination dares to hold. And in this uncertainty lies the haunting beauty of the Milky Way, a cathedral without walls, a boundary that dissolves into shadow, a riddle still unfolding across the night. To ask the size of the Milky Way is to ask a question with shifting answers. For centuries, the figures have wavered, tens of thousands of light years, then 100,000, then far more. Even today, the estimates remain unsettled. Some astronomers argue that the luminous disk spans about 100,000 light years. Others suggest 200,000, perhaps more, as faint structures and hidden stars continue to stretch the scale outward. The galaxy, once thought compact and neatly bounded, now appears more like a vast and uneven continent whose shorelines dissolve into haze. Within this uncertainty lies a tantalizing possibility. If the outer regions are populated with stars too faint to detect, then the Milky Way may contain not hundreds of billions of suns, but closer to 1 trillion. Many of these would be dim red dwarfs, the quiet embers of stellar creation, or brown dwarfs, objects too small to ignite fusion yet still lingering as silent members of the galactic family. Their collective presence would reshape the census of stars, expanding the true population far beyond the familiar points of light visible to telescopes. In the outskirts of the disk, such faint stars could stretch into a nearly invisible ocean, blurring the distinction between where the galaxy ends and intergalactic space begins. But the puzzle of scale is not confined to starlight. It is anchored to something deeper, something unseen. Dark matter remains the dominant mass of the Milky Way, a hidden halo enveloping the luminous spiral. Theories suggest this halo extends at least 500,000 light-years in every direction, a sphere dwarfing the disk itself. Within this envelope, visible matter is little more than decoration, a thin frosting atop an invisible structure. Simulations predict the halo is not smooth but laced with clumps and streams, the remnants of smaller halos consumed during the galaxy's growth. These ghostly structures may never be seen directly, yet their gravitational imprint shapes the way stars move, the way the disk warps, the way the Milky Way holds together. General relativity adds another layer to this mystery. Einstein's theory describes how mass and energy curve spacetime, dictating the motion of stars and gas. Within the galaxy, relativity ensures that gravity's pull is not simply a Newtonian force but a warping of the cosmic fabric itself. It is this curvature that holds the spiral arms in their slow dance, that guides the orbit of stars around the central black hole. Yet relativity also deepens the enigma, for when the equations are applied to the motions of the outer stars, they predict far less mass than is observed. Without dark matter, the Milky Way would unravel. The paradox lies at the heart of galactic dynamics. The visible does not explain the real. Some astronomers have wondered whether this invisible mass is even necessary. Alternative theories like modified Newtonian dynamics, MOND, propose that gravity behaves differently on galactic scales, instead of unseen matter. Perhaps the laws of motion themselves shift in the weak gravity regime. MOND has been tested against galactic rotation curves and in some cases explains them without invoking dark matter, but it struggles to account for other phenomena, such as the cosmic microwave background or the behavior of clusters of galaxies, exotic matter, emergent gravity, hidden dimensions. Each idea has been proposed, each carries intrigue, and each remains unproven. The Milky Way becomes not only a galaxy to measure, but a laboratory to test the very nature of gravity itself. All of these speculations lead to a profound question. Does the Milky Way even have a definable edge? In one sense, yes. The stellar disk tapers into thinness, the gas density falls, the number of stars dwindles. But in another sense, the galaxy simply fades. The halo stretches outward, its stars sparse but unending, its dark matter invisible but immense. At some point, the density becomes so low that the galaxy blends into the intergalactic medium, into the cosmic web that binds galaxies together. The edge of the Milky Way may not be a wall, but a gradient, a slow dissolution into the universe at large. This perspective reframes the very concept of scale. The Milky Way is not a static structure like a stone cathedral with fixed walls. It is a dynamic field, a concentration of stars and dark matter woven into the fabric of space-time. Its size depends on what one chooses to measure: the bright disk, the faint outskirts, the halo of ancient clusters, or the invisible dark matter envelope. Each answer is true and yet incomplete. The Milky Way becomes not a number, but a spectrum, a reality whose boundaries shift with every new observation and every new theory. The implications ripple outward. If the Milky Way has no clear boundary, then neither do other galaxies. They are not isolated islands but overlapping spheres, halos brushing against halos, streams of stars exchanged between neighbors. Even now, the Milky Way's dark halo mingles with that of Andromeda, long before their visible disks collide. The cosmos is not a collection of discrete objects but a continuum, a web of mass and light without absolute edges. In this sense, the quest to define the size of the Milky Way is as much philosophical as scientific. It asks what it means for something to have a boundary in a universe where matter fades into void, where light dissolves into darkness, where even gravity stretches infinitely. The galaxy is both a home and a horizon, both a structure and a question. And within its blurred edges lies the reminder that certainty is not the end of inquiry, but the beginning of wonder. The quest to measure the Milky Way has always been a struggle against distance and illusion. For centuries, each generation of astronomers built new tools, sharpening the focus of humanity's gaze. In the modern age, this struggle has grown into a revolution. The galaxy is no longer charted by patient stargazing alone, but by spacecraft, global networks of radio antennas, and supercomputers running simulations as vast as the cosmos itself. At the forefront of this revolution is Gaia, the European Space Agency's ambitious observatory. Launched in 2013, it has transformed the night sky into a map of unprecedented detail. With a precision beyond imagination, Gaia traces the positions, motions, and brightness of nearly 2 billion stars. Each data release redraws the galaxy with finer strokes, turning the Milky Way from a blur into a living, breathing system of stellar currents. What once were static pinpoints of light are now revealed as rivers in motion, each star carrying a story of birth, migration, or exile. Gaia does not simply map stars. It maps time itself, unraveling the choreography of the galaxy across millions of years. But Gaia is not alone. Another tool of extraordinary power is very long baseline interferometry, or VLBI. By linking radio telescopes scattered across Earth into a single virtual dish the size of the planet, VLBI achieves resolution sharp enough to track pulsars to within millimeters. These pulsars, collapsed remnants of massive stars, rotate with clock-like precision, their radio pulses sweeping through space like the beams of cosmic lighthouses. By tracking their timing, astronomers anchor distance scales and chart the structure of the galaxy with exquisite accuracy. VLBI offers the ability to pierce through dust and distance, to place markers within the Milky Way, where no optical telescope can reach. While Gaia and VLBI trace the luminous, another frontier unfolds in the invisible. Dark matter, the unseen majority of the galaxy's mass, cannot be measured directly. Instead, supercomputers run vast simulations, filling space with billions of particles of this hypothetical substance. These simulations reproduce the cosmic web, the clustering of galaxies, and the rotation curves that betray dark matter's presence. They suggest the Milky Way's halo is not smooth but laced with substructures, fragments of smaller halos consumed over billions of years. In the silent language of algorithms, the invisible becomes modeled, hinting at shapes and scales that observation alone cannot reveal. And yet, the simulations remain hypotheses. To prove the existence of dark matter requires another kind of tool: detectors buried deep underground, shielded from cosmic rays, waiting for the faintest whisper of interaction. Particle physics laboratories from Italy to the United States, from China to Japan, operate instruments designed to catch the rare collisions between dark matter particles and ordinary atoms. So far, the detectors have remained silent, but the search continues because a single confirmed detection could transform the debate. To weigh the Milky Way with certainty, astronomers must one day measure not just its stars, but the dark substance binding them together. The future of this investigation lies with telescopes still rising. The Vera Rubin Observatory, soon to begin its 10-year legacy survey of space and time, will sweep the entire southern sky repeatedly, capturing changes in brightness and motion on a scale never before attempted. Its sensitivity will reveal faint stars at the galaxy's edge, ultra-diffuse dwarf galaxies barely visible, and tidal streams stretching across the halo. The Nancy Grace Roman Space Telescope, scheduled for launch in the coming decade, will offer a panoramic infrared view, cutting through dust to reveal the hidden skeleton of the Milky Way's structure. Together, these instruments promise to extend the frontier of knowledge to the galaxy's blurred outskirts, to the faintest stars whispering at the edge of the dark. With each new survey, estimates of the Milky Way's size shift again. The mass may be closer to 1 trillion suns or perhaps nearer to. The stellar disk may reach 100,000 light-years across, or the halo may stretch nearly 1 million. Each number carries uncertainty, each revision reshaping the boundaries of our home. The debates among astronomers are not signs of failure but of progress. For the Milky Way is not a static object waiting to be measured once and for all. It is a dynamic system, alive with streams, mergers, and invisible scaffolding. Its size is not fixed but evolving. The ongoing testing is both humbling and exhilarating. Gaia refines stellar maps. VLBI anchors distances. Supercomputers run scenarios of dark matter. Future observatories extend the search to the faintest outskirts. Particle physics collaborations listen for the silent signature of the unseen. Each method alone is incomplete. Together they weave a net around the galaxy, pulling its contours into view piece by piece. And yet, the paradox deepens. The better the instruments, the stranger the galaxy becomes. Boundaries blur. Simulations suggest substructures too faint to detect. Data reveals stars moving in unexpected ways, hinting at gravitational tides from companions unseen. The Milky Way, instead of resolving into clarity, becomes more intricate, more alive, more enigmatic. The galaxy's measurement is not a finished act, but a continuous process. It is a pursuit stretching across generations, a slow unveiling of a structure too vast for one lifetime to comprehend. And as each tool sharpens, humanity's place within it grows smaller yet more wondrous. For to know the size of the Milky Way is not merely to know a number. It is to glimpse the architecture of the cathedral in which life has emerged. A cathedral whose foundations lie in the invisible and whose spires dissolve into the unknown. To measure the Milky Way is to confront both knowledge and humility. After centuries of searching, humanity has begun to glimpse the scale of its galactic home. The luminous disk stretches 100,000 light-years across. Its halo swells far beyond, perhaps 1 million. Within it turn hundreds of billions of stars, each with the potential to cradle planets and stories of their own. And yet the truth is not a boundary but a paradox. The sharper the measurements, the more the edges dissolve into uncertainty. The galaxy is not a rigid structure but a living system. Its spiral arms are not permanent fixtures but rivers of motion, shifting as stars are born, migrate, and die. Its halo is not a clear shell, but a tapestry of stellar streams, remnants of ancient collisions. Its mass is not a fixed number, but a shadowed estimate bound to the unseen grip of dark matter. Even the act of measuring reveals the impossibility of finality. The Milky Way is not something to be defined once and for all. It is something to be pursued endlessly, like a horizon that recedes as one approaches. This pursuit brings perspective. Earth orbits a modest star on the outer edge of the disk, far from the galactic center. The Sun is one of hundreds of billions, itself insignificant against the mass of the galaxy. Humanity's entire history, the rise of civilizations, the sweep of empires, the whispers of art and memory, unfolds on a world smaller than a dust mote in the sea of the Milky Way. The galaxy itself, for all its vastness, is only one among perhaps 2 trillion galaxies in the observable universe. Each of them a structure of staggering scale, each of them a cathedral of stars. The fragility of this position is undeniable. In the face of such immensity, human life appears impossibly small, brief against the backdrop of cosmic time. Stars live for billions of years. Galaxies evolve over eons. Civilizations rise and fall in less than a flicker. And yet, within this brevity lies something remarkable. A species of fragile beings, born on the surface of a small planet, has not only wondered at the stars but built tools to measure them. From Galileo's telescope to Gaia's billion-star maps, from myths of rivers of light to the simulations of dark matter halos, humanity has lifted its gaze from the ground to chart the very structure that cradles it. In this act of comprehension lies a quiet triumph. The Milky Way does not diminish life, it elevates it. For the same universe that renders humanity small has also given it the capacity to see, to question, to imagine. The Cathedral of Stars is not mute. It speaks through the language of light, through the timing of pulsars, through the bending of gravity itself. And humanity, despite its fragility, has learned to listen. The paradox of knowledge is that it opens into mystery. The closer the galaxy is measured, the more elusive its true boundaries become. The stars reveal structure, but dust conceals it. Simulations sketch dark matter halos, but their substance remains unknown. The Milky Way appears larger, more complex, more uncertain with every advance. What began as a myth of a glowing river has become a riddle of dark matter and tidal streams, of twisted disks and colliding futures. The more we know, the deeper the mystery grows. In this, the Milky Way becomes more than a scientific object. It becomes a mirror for reflection. It is both home and horizon, the place where humanity belongs and the place it will never fully comprehend. It is the cradle of life, yet also the abyss of perspective. Its stars form a cathedral of light, not with walls of stone but with corridors of fire and shadow. And its doors do not open to certainty, but to infinity. To stand beneath its glow is to feel both insignificance and wonder. To realize that life is a fleeting spark within a trillion suns, and yet that spark has learned to trace the scale of the galaxy itself. The Milky Way is not only the stage upon which humanity lives, it is also the horizon against which meaning is measured. Its size humbles, its mystery inspires, and its presence in the sky reminds all who look upward that existence is both fragile and vast, temporary and eternal. The galaxy will continue to turn, its arms will wind, its halo will stretch. In 4 billion years, it will merge with Andromeda and become something new. Long before then, humanity's future may have shifted beyond recognition. But the story of the Milky Way will remain, written in the stars that outlive civilizations, in the dark matter that shapes them, in the infinite horizon that forever eludes completion. The final truth is both unsettling and beautiful. To know the Milky Way is not to know its end. It is to accept that its boundaries are blurred, its scale uncertain, its essence mysterious. Yet within that mystery lies meaning. For the galaxy is not only where humanity lives, it is the reminder that existence itself is part of something immeasurable, a cathedral of light, an endless horizon, a riddle written across the night.